Whenever you embed these kind of devices in those kind of devices, they're called smart, or they become smarter. So smart roads, smart health, smart grids, etc. So that's something that people are already doing. And since it's a two-way communication channel now, you can sense the network as well as push information back. You can deploy some incentives if you want. Okay. So feel free to ask me questions, okay, or discuss things. As I've said, I've just learned some of these things over the past 2.5 years. So hope to be able to answer. So let me describe some of the problems and opportunities for us. Let's look at road congestion again. I told you this number before, but there's $87.2 billion. What are we hoping to do there? We can't get rid of it, right? It's not, it'd be silly to think that all 87.2 can be taken out. But suppose we got rid of 10% of it, okay? Then that could be interesting, okay? Because compare the other numbers we've seen that were large in the bailouts. But the bigger thing is this thing here. Everybody's getting very sensitive to emissions. EIA is Energy Information Administration, part of the DOE here, and the other one's the UK source. So emissions are a very large portion, transportation-related emissions are a very large portion of carbon emissions, and everybody's trying to get after this. And there's also, of course, ignore other things like traffic accidents and parking. Parking is a big headache for cities. So these are sort of the huge cost of transportation. So 87.2 billion is one portion, but there's all sorts of other things. So here is an example. I don't know if people know this. There was a 9-day traffic jam in China. Everybody know? Okay, you were stuck on the road for 9 days. So in fact, what happened was a couple of reporters going in the opposite direction on those roads thought, oh, we'll go to the back of the traffic jam and then come into Beijing with it. And they went on the other side and got stuck for 9 days. Okay, and so this is sort of very common. You've seen traffic jams in other countries, I'm sure, but China and India are notorious. You look at carbon footprint, there's this numbers from the Singapore mass rapid transit system. If you take the public transportation system for 9,000 kilometers per year versus your own car, the numbers look like this. So it's 132 kilograms versus 230. And the way this is all measured is this penance that you need to do to get rid of this emissions is measured in how many trees you need to plant. So this is the way to think of offsets. And so there's obviously a different number here. And so if that's so bad, why don't we all jump into public transit systems? Really, it's just all about adoption. In the US, as you know, we have a very poor record of public transit use. So only 2% of our trips all trips in the US are public transit trips. Singapore is 48%, but Hong Kong, for example, is 94%. Okay, so this 2% number, I found an amusing use of it in this magazine, The Onion. Okay, so all right, so we do prefer. So you've all seen this public transit, yes? Yeah.
Singapore is a city.
It's also a country, as it happens. No, I understand. But if you look at, Manhattan is an exception in the US. It's an exception. For example, even DC.
Singapore is an exception in the greater metropolitan Singapore area.
It's not true, actually. The other cities there, like Bangkok, Manila, I'm talking about Bangkok is a city. Manila is a city.
Right.
Okay, so they have very high. Oh, I see. Your point being that, but the density in these cities is a fairly significant portion of the population. But compare cities like LA and San Francisco in the US. They're big cities, but the transportation record is very poor. Right? So it's easy, maybe I should just mention a counterexample. So let's look at this public transit systems. What happens here is also people sort of, people have seen this thing. It's if you go to YouTube and do crazy Japanese train, you'll see this thing. But this is typical. So when people, those people in uniform are actually employees of the train company. It's a job called wuxia. You can apply for it, okay. And it means passenger arrangement staff. Okay. So this is what happens in Manhattan as well, right? For example, so people push each other into. Okay, so other cities have same problem. So it's not like public transit use is high means everything is great. People don't enjoy the experience, right, necessarily. So it's all over the place. So the question is, how can you decongest these things, right? Congestion shows up in different places. So what are some current solutions, whether it's public transit or private vehicles? Current solutions are congestion charging or road rationing, one of these two. Congestion charging means you get into a congested area and you pay. London, Singapore, Stockholm are famously have deployed this, but there are many other cities. It's viewed as yet another tax by many citizens. It's something that they don't like. London's got £8 per entry into central London now. That's pretty high. People have not liked it. The term undemocratic here usually means that it favors the rich, right? If you can afford it. Cities, should inner cities be only accessible to the rich, if on private vehicles, etc. And expensive as an engineering system, the London system is actually it uses video surveillance cameras, and it's pretty expensive to run the system. Okay, the other option is road rationing. So if you by fiat say that one or more days of the week you cannot drive, depending on license plate number, then you end up in this sort of systems deployed in South America and Greece and China. And the problem, of course, here is that it puts all the burden on enforcement. I've heard that in China, recent solutions to get 2 cars, your Monday, Wednesday car, and Thursday, Friday car. In Greece, it's 2 license plates. I mean, this was a student of mine said this, but it correlates with the economies in these 2 places now, right? So the other option is to add capacity. Of course, congestion it begs for capacity addition. So this is how all public transit systems do it. Here's a newspaper article from Singapore. The buses cost about $250,000 to $300,000 just to buy. The small versions, the longer, what are called bendy buses are more expensive. Double deckers are more expensive. Trains are $20 million each in Singapore, so that's a pretty heavy cost of capacity addition. And usually it just tends to peak up the congestion. The moment of congestion just gets compressed. So what's our approach? Our approach is try and use incentives. And so let's not do charging. Let's not necessarily charge anybody or charge everybody. For sure, don't charge everybody. So let's charge the congestors and pay the decongestors. That's one way you could do this. In fact, what you'll see is that we will just never charge anybody, because at least in the pilots that we have run. Okay. But the key point is that to decongest, you really need to just remove 10% of the load, right? So we all seen this sort of load versus delay curves, and they're always like this. As load approaches capacity, delay goes to infinity. And so if you remove some small percent of the load, reduction in congestion measures is much more significant. Okay. So the question is, which 10% of the load will you remove? Well, if there's enough heterogeneity in the utility function of your population, some people will probably take the money and give away space, right, in the peak time. And that's all. That's just it. So let's go find this 10%. Okay? So we need some money to go play with this sort of thing. We ran an experiment about 2.5 years ago in India with 20,000 people. And we had, this was the company Infosys. I'll describe the experiment, but we had $2,000 a week to give away. Okay, $2,000 a week for 20,000 people as a population pool, but actually 14,000 are all that participated for various reasons. But still, if 10,000 of those people responded and wanted to go, in the off-peak times, you only have 20 cents a week to pay with, right? It's not enough to incentivize anybody. So we did this thing of micro raffles, and I'll tell you how this goes. We're going to use this idea that in games with low stakes, players are risk-seeking. Okay, it's just the way we human beings are wired. I want to demonstrate this to you. So here's a participatory game. I'm going to offer you an envelope, a 2-envelope game. This is a fairly standard example in economics. One is a deterministic $100. The other one is $11,000, but with 1% chance. Okay, otherwise it's empty. How many of you want the riskier, the second option, envelope 2? Okay. See, this is a group of faculty, and I should have made this $1,000 or 110,000 or something. Okay, but everybody's seen, like, there's probably 15% of you who said yes. Let me reoffer the game to you: $1 deterministic and $110. Everything scaled down by a factor of 100. Now who wants the deterministic option, the $1 envelope? All right. Okay. They must not be paying a lot in MIT. David Carter is paying. And one over here too. So let's see what happens now. So the point is that not many people weren't interested in the $1 option. And if I offered it to you at 5 cents, which is the cost of recycling this in the state of California, the empty bottle, we'll see what people did, okay? So the theorem is that if you choose envelope 2 in version 1, I'll tell you this precise statement next slide, you're guaranteed to choose it in version 2. So if you're already risk-seeking here, you're guaranteed to retain that in this part. This is with concave utility functions, of course, but if it's convex, then you're risk-seeking anyway. The nice thing about theorems like this in economics is if this is not true, then you're irrational, right? I like that. Right. So here's the precise statement that if you have a concave utility function and satisfies either of these two conditions, then this is true. What this says is, so let's look at this. This is a concave utility function. So by Jensen's inequality, without this delta here, this is guaranteed to be reversed, okay? Because it's concave. And the reason with this delta, which is small, so in our example there is 1 over 1.1, that this inequality can reverse, is that, that's the statement of the theorem, that this is true. This is the condition we came up with, but that turns out the literature has that previous condition. Ken Arrow's book from 75 has this, on risk, has this. This is more general than that. Everything that satisfies, that will satisfy this, but we don't know how to interpret our condition, but it's a condition, okay? So, but you see what I'm saying, that it's possible. Let's just start applying this idea. So we're all here, I'm sure we're all frequent flyer miles program members. Let's say you go to your airline and want a ticket to Europe, and it's 50,000 miles is how much it costs, but that's option 1. Okay, this is the deterministic option. Envelope 2, option 2, gives you the same ticket for 500 miles with 1 in 100 chance. Okay? So this is an option, okay? For every 100 people that exercise this option, one of them, on average, will be the lucky winner. And the others may not be so pissed off because what do they lose? Not much, okay? And if you look at how many people have 50,000 miles, it's not many. There's some heavy tail distribution. Very few people put on 50,000 miles a year. I mean, this room, of course, is an exception, okay? But in general. So here's option 3, unattractive. The same thing with 25,000 miles with half chance. The stakes are much higher now, and I'm just not interested. I mean, 1 in 2 people will be really pissed off, okay?
What's the gamble? So you give them the miles, and then they say, okay, you got the ticket, or else they say, nothing, you took your miles.
Exactly. Okay? You don't get to, yeah. You lose your miles. So faculty salary increases, obviously, another example, right? We all know this. 2% per annum, cost of living type of thing, right? Except once in 10 years or something. And you could do this, or the dean could offer it at 200% with 1 in 100 chance, okay? And this could work, right? So let's look at some real experiments. Sorry? Okay. Okay, sorry. So let's look at a real example. This is an experiment we conducted at Stanford in a freshman seminar course I taught in spring. This is the exact thing I told you. You recycle. So we gave all these options. We gave the deterministic option, and there's different, all the usual currency notes in circulation. We gave all these options with the odds adjusted so that the expected value is everywhere 5 cents. And the question is just to find out the risk profile. Okay, what would people choose? Okay. So if everything we thought, this hypothesis, all grand hypothesis is true, what we should see is if we have 5 cents here and $1 like this, more and more people must choose the riskier and riskier options. So it should be convex, right? In the event, this is what we found. Lots of units, this is how many units got recycled. Lots of units at 600, close to 600, but the rest of it looks about right. $50 is an anomaly. I don't think we all know how to spend $50 because it's not heavily in circulation. There's some bias. I don't know how to explain it. Okay. But the interesting thing is, was this a counterexample of the whole theory, right? Well, the thing is that that's due to only 3 recyclers. So these guys brought like really big bags and recycled all the units with us, all of them for 5 cents. We couldn't induce them to gamble even one of them. Okay. and they would have gone to the recycling facility. They just found us to be closer. Okay. So that's the finding, right? So it's consistent. So let me just get to something. Yeah.
What is that? There's more data. There's real data. What is this?
It's real data.
It's real data.
So 1 week, 18 hours over 1 week, the undergrads in this course set up a booth and recycled. Okay.
So did people pick different numbers for if one of your 170 recyclers brought in a bunch of cans, they could
Yes.
gamble big on this can?
Sure. It's literally like slot machines, and cans are like 5 cents each. Except. So let's look at some pilots, real pilots. So as I mentioned to you, there's this is the thing that got us started. If people have been to Bangalore, you know how bad the traffic there is. So in fact, while going to Infosys, I was stuck in such a traffic jam on this is the notorious Hosur Road, which is like really bad. Yeah. So, and then we spoke to this company, and then one thing led to another, and we ran this project. So what this means is that, you know, everybody in this company who works in this company lives in this greater Bangalore area, and this is about 15 to 20 kilometers. You go down to the Electronic City to work. That's where the office is. And the company has 20,000 people going down every day and then going back up. Okay, so it runs buses, like somewhat like the buses that other companies run, and bringing people down. About 12,000 people go in these buses. Okay, so the remaining people either drive themselves or motorbike down, or So a dominant portion of these people actually take these buses. And let me tell you what. There's a paper we wrote in appeared in Network Economics 2009. It has all the details, but I'll summarize. So if you look at the off-peak time and compare that to the peak time, and look at these buses, I'm going to show you GPS traces collected from inside these buses on a particular day. It's essentially any day. The data shows you. So there are about 20% of all commuters on this side, 80% of the commuters are on that side, because that's just the definition of peak. So when you raise these buses, this blue guy just made it here in 29 minutes. Okay, that's like propagation time. Whereas that guy is still stuck over there, and this was a telling video to show these people, because 80% of the people are seeing their bus lose this race very badly. Okay, so 52 or 53 minutes behind, just traffic jam. Okay, and this is an everyday story in that company. And so now we incentivize these people we created like a frequent commuter program, like a frequent flyer miles program. So depending on when you arrived, you earn more credits, or somewhat, more credits, or no credits. Okay, and so everybody had an account of their behavior. This allowed us to slot them into a pyramid, status pyramid. But the important thing is there's an incentive mechanism, an algorithm that just matches the people in the dollars, or the rupees in that case. So, I'll just show you how this works. The status pyramid arrange people like this. So you're either, if you had only 3 credits, you were here in this level, up to at least 3 credits you were here, sorry. Okay, 48 prizes, each worth 500 rupees. That's about $10. Okay, if you're at least 7 credits, you got into this level, and so on. Okay, at the topmost level, you stand to win one of 2 12,000 rupee prizes. Okay, and you have to have at least 20 credits to get up there. So it's like a status pyramid and so on, right? So the algorithm runs like this. Every week on Saturday, we ran this algorithm where you pick 2 people from the level at the top and gave them these prizes. The person who didn't win was automatically qualified for the draw at the next level, and so it went. And when there was more money, the money went down, and that never happened. But it's the case for the algorithm. So people who didn't win at a certain level automatically were in the draw at the next level, and so on, right? So you get this idea that with a greater chance you win if you are higher up, and you stand to win more money. Okay? The paper is all the details, but the important thing is this, is that we got rid of 8 buses from the fleet. This capacity addition, which the company was doing over time to address this peak problem, we got rid of these 8 buses. Each of these buses costs 200,000 rupees a month to rent. So just 2 of those buses, enough to pay for the scheme, the remaining 6 are savings. Okay? And there's fuel savings and other things, commuters, shorter commuting time, etc. So this was the project we ran for 6 months. And that's the full-blown example. Since then, we've sort of done other deployments, and I'm going to summarize just one slide at a time. Singapore, Raffles is a project called Travel Raffles, and our goal is the government is sort of sponsoring this project. Our goal is to shift move people from private to public transportation and incentivize off-peak travel. And so, there are various reasons for doing this, carbon being one, and people have complained about transportation. So Raffles it's sort of, the sensor here is the smart card. These readings are going to be made available to us. So you're a Singapore commuter, and you leave one station, and you're checking into the train system, and then you swipe yourself in and come out the other side. We will get access to that record. And this goes into like a portal, which will be like your airline miles portal. So you can look at these credit histories and so on. And then you can go redeem this for cash or cash equivalents. Okay. So we have money from the government for doing this, but also there are sponsors like the cell phone carriers. You could win 100 cell phone minutes as a Singaporean for doing your good deeds in the public transport system, or you could win, other things like an airline. Jetstar Asia is going to give us travel vouchers to give away. Okay. So the point here is that there are many networks we use. Transportation type networks are extremely resource constrained, and traffic is disliked here, right? You look at these other networks, computer networks, infinite bandwidth. We love traffic. We want to be the #1 destination on the internet, okay? So you do your good deeds here, and we'll give you some goodies on this side, okay? It's a nice trade-off, it seems, okay? So that's all I'm going to tell you about the Raffles project. Steptacular is a project that is currently underway. We're into 7 weeks with Accenture employees. So every Accenture employee that wants to participate, there are about 5,000 now, puts on a pedometer like this and walks up, all the trips you make, the bathroom, the conference room, the parking lot, whatever, okay? All of that's counted. There's something called the Presidential 10K Challenge. This is run by the White House. It was started by the previous administration. It was meant to get Americans to walk 10,000 steps a day at least. That's about 5 miles. And last year, Obama called on companies to recognize the efforts of the employees. And Accenture had a program where if you walk 1 million steps, that's 500 miles, okay, you will get $100. Hardly anybody doing this. It's like saying, climb Everest and then I'll give you a big reward or something, right? So what we did was this micro raffles. At the end of the first day, you could try and see if you could win something. So I'll stop this with here, and I'll just show you. This website's available. We're running this on the Amazon. So you can go to steptacular.org and you can see this. You can't log in, of course. You need to be an employee of. So we've taken all this. So this is how many steps all of Accenture's participants in our program have taken until now. This is how many miles they've walked. So we have a lunar landing team going right now. They're about 94% on their way, combined, on their way to the moon. We're going to land them there and bring them back. Okay, but this sort of thing gets community sort of. This is what I meant by the social component. So if you mouse over this, you can see the contributions of the big offices like Chicago. This is spouses and unclassifieds. But here's Washington, D.C., etc. So you can see how much each of these offices has contributed. And you can't, but I can log into this account and, there's a buddy list. So it's a little like Facebook, but we didn't want to run it on top of Facebook for various reasons, some company policy, etc. And, but we've created our own buddy list. There's a news feed, etc. But the random redemption thing is no longer a lottery that we run every week. This is a headache to do. You want to distribute this out somehow, okay? And it has to be interactive and to be interesting. So we realized that it was actually came out of the recycling experiment on campus when we started doing it. We just offer a chance. We will let you play a game of chance. Okay. In this case, it's shoots and ladders, and you keep rolling the dice using your credits. You earned all these credits to your good deeds. You go and roll these dice, and some of these die rolls may result you in some money. We've paid out $28,000 until now. The company gave us $1 per participant per week. That's the deterministic amount. We've just told them that that's too little because Stanford already offers something like $3 per participant per week. Not in exactly that way, and so they've upped it. So now we have $3 per participant per week to pay out. Okay, thank you.
For a couple of questions. David?
I guess along the lines of David Kempy's talk, it's easy to ask, how much of this work
So it's a bit of the latter. Experimental economics has been doing this for many years, right? This sort of thing. And what they have, the one major way in which this differs is, excuse me. The one major way in which this differs is that most of these economic experiments have about 100 people, 500 people, except the marketing guys. The marketing guys have incredibly large experiments, okay? But it's more a survey-based universe in marketing. They just want to know what you think. They don't want you to change your behavior in any way, okay? And then there's the psychology folks as well. Sometimes they're after changing your nature, like in prison reform and stuff. We don't want to change anybody's nature. We just want to change their behavior, right? And so is this observation mostly coming from networking that all you need is like 15%, 20%, and then let the network effect do the rest of the work, if possible, right? Why do people play Zynga type games, right? Completely useless, but there's like a huge, stickiness to it. So that's the sort of thing where, it's more models, but, mixing engineering and economics in some interesting way. It's building a large-scale system, basically.
How do you see this scaling to millions of people?
I can see the Singapore thing scaling. In fact, that's the goal. After the first year, which is the pilot phase, in Singapore, we've got money for 20,000 people, or 100,000 show up. At least we get oversubscribed. There's some standby, there's some backup options. But after that, the government's going to deploy. If it succeeds, the government's going to deploy it to all the 2.5 million customers, commuters. Sorry, right? So that's the goal. It's we've built these networks, right? We've built all these like massive scale networks. This is not that difficult.
Last question.
So Boink is the online software where people can sign up to run applications like SETI at home and Foley at home, and they've done all these experiments. So how do you motivate people to donate their free cycles and have lots of competitions? I'm wondering, is there any similarity between what they do and what you do?
Yeah, so there are a lot of these things also. Like now, look at Foursquare and stuff, right? They're trying to give away some part of something that belongs to you, like where you are, and in exchange they'll give you some recognition, some social recognition, and not much else actually. Okay, those are sort of not the normal behaviors that we undertake. We're sort of looking at commuting, which we must all do, at least now, and then energy expenditure, which we must all do, etc. Right? So we're sort of taking the necessary behaviors that we must all exhibit, and then just trying to nudge that. Walk 1 million steps. That's 500 miles. Okay, you will get $100. Hardly anybody doing this. It's like saying, climb Everest and then I'll give you a big reward or something, right? So what we did was this micro raffles. At the end of the first day, you could try and see if you could win something. So I'll stop this with here and I'll just show you. This website's available. We're running this on the Amazon. So you can go to steptacular.org and you can see this. You can't log in, of course. You need to be an employee of. So we've taken all this. So this is how many steps all of Accenture's participants in our program have taken until now. This is how many miles they've walked. So we have a lunar landing team going right now. They're about 94% on their way, combined, on their way to the moon. We're going to land them there and bring them back. Okay, but this sort of thing gets community sort of. This is what I meant by the social component. So if you mouse over this, you can see the contributions of the big offices like Chicago. This is spouses and unclassifieds. But here's Washington, D.C., etc. So you can see how much each of these offices has contributed. And you can't, but I can log into this account and, there's a buddy list. So it's a little like Facebook, but we didn't want to run it on top of Facebook for various reasons, some company policy, etc. And, but we created our own buddy list, there's a news feed, etc. But the random redemption thing is no longer a lottery that we run every week. This is a headache to do. You want to distribute this out somehow, okay? And it has to be interactive and to be interesting. So we've realized that it was actually came out of that recycling experiment on campus when we started doing it. We just offer a chance, we will let you play a game of chance, okay? In this case, it's chutes and ladders. And you keep rolling the dice using your credits. You earned all these credits to your good deeds, you go and roll these dice. And some of these die rolls may result you in some money. We've paid out $28,000 until now. The company gave us $1 per participant per week. That's the deterministic amount. We've just told them that that's too little because Stanford already offers something like $3 per participant per week. not in exactly that way. And so they've upped it. So now we have $3 per participant per week to pay us. Okay, thank you.
For a couple of questions. David?
I guess along the lines of David Kempy's talk, it's you can ask how much of this work required is in the proper modeling, and then how much is in mathematics. This, if you spend all your time trying to figure out what mathematical models are accurately predictive of what people are going to do, or is it more in taking understood models from economic perception and exploring the mathematical aspects of it?
So it's a bit of the latter. Experimental economics has been doing this for many years, right? This sort of thing. And what they have, the one major way in which this differs is, excuse me. The one major way in which this differs is that most of these economic experiments have about 100 people, 500 people, except the marketing guys. The marketing guys have incredibly large experiments, okay? But it's more a survey-based universe in marketing. They just want to know what you think. They don't want you to change your behavior in any way, okay? And then there's the psychology folks as well. Sometimes they're after changing your nature, like in prison reform and stuff. We don't want to change anybody's nature. We just want to change their behavior, right? And so it's this observation mostly coming from networking that all you need is like 15%, 20%, and then let the network effect do the rest of the work, if possible, right? Why do people play Zynga type games, right? Completely useless, but there's like a huge, stickiness to it. So that's the sort of thing where it's more models, but mixing engineering and economics in some interesting way. It's building a large-scale system, basically.
How do you see this scaling to millions of people?
I can see the Singapore thing scaling. In fact, that's the goal. After the first year, which is the pilot phase, in Singapore, we've got money for 20,000 people, or 100,000 show up. At least we get oversubscribed. There's some standby, there's some backup options. But after that, the government's going to deploy. If it succeeds, the government's going to deploy it to all the 2.5 million customers, commuters. Sorry, right? So that's the goal. It's we've built these networks, right? We've built all these like massive scale networks. This is not that difficult.
Last question.
So Boink is the online software where people can sign up to run applications like SETI at home and folding at home, and they've done all these experiments. So how do you motivate people to donate their free cycles and have lots of competitions? I'm wondering, is there any similarity between what they do and what you do?
Yeah, so there are a lot of these things also. Like now, look at Foursquare and stuff, right? They're trying to give away some part of something that belongs to you, like where you are, and in exchange they'll give you some recognition, some social recognition, and not much else actually. Okay, those are sort of not the normal behaviors that we undertake. We're sort of looking at commuting, which we must all do, at least now, and then energy expenditure, which we must all do, etc. Right? So we're sort of taking the necessary behaviors that we must all exhibit and then just trying to nudge that